go through 15 and 23 here. So guys, if you didn't get the homework done, feel free to do these with us. Like, it's good for you guys to go through, or if you guys got these questions wrong, you should probably be writing this down and practicing this. In 15, so we obviously have to decide which side to go for first and then which trig function to use. So I'm going to list my SOHCAHTOA over here. So I'm going to label my triangle based off the angle I know. So this is 50 degrees. This is my opposite. This is my hypotenuse. And then this is my adjacent. And Nolan, I think this was yours. Do you know what type you tried? No. Okay, let's look at it. So if we have the opposite side, I know I have to use one of the trig functions with the opposite side. So I have to use either sine or tangent. Does anyone have a preference? No? Okay, we'll go sine. So sine of our angle, which is 50 degrees, equals opposite over hypotenuse, O over H, so 8 over N. So this is one of the ones where the variable's in the denominator. So I have to put this over 1, and then I can cross multiply and set them equal. Now, I feel like these are either, either you're multiplying or you're dividing these. So if you're able to do this without showing a lot of steps, that's fine. I would suggest showing me what you set up as your proportion. But then if you don't have to show all these steps, it's okay. Just make sure you do your work right then, so I can give you credit, or partial credit if you made a mistake. So we have to find our N value there. So 8 divided by the sine of 50, and I get about 10.44. So 10.44 for this hypotenuse. Now it's up to you. At this point, you can either use Pythagorean theorem, or you can use the other trig function. You can use tangent to find angle M. It's kind of up to you guys, whichever one you prefer. So I don't know, do you guys have a preference? Should you do tangent or Pythagorean theorem? What do you think?
Theorem.
Tangent. So then tangent, we're going to do opposite over adjacent. Kind of once you get good at these trig functions, I think they're just as easy as doing the Pythagorean theorem. It's kind of less, I don't know, kind of monkeying around with squaring things. And so opposite over adjacent. Divide by the tangent of 50. We have 8 divided by the tangent of 50, which is like 6.7. 6.71. And so that's my M value. All right, we're going to go to 23 then. So this says find the missing side length, and then they just want you to find sine of x, cosine of x. So kind of just setting up this triangle here. So find the missing side, and then we're going to set up sine of x and cosine of x. Pythagorean theorem because I don't know any angles at this point. So I'm going to have to do a squared plus b squared equals c squared. Now don't forget, be careful about squaring the 8 square roots of 2. So when I do that, I really have to do 8 square roots of 2 times 8 square roots of 2. So it's going to be 64 square roots of 4. So 64 times 2, which is 128, I believe. And then I'm going to add those together. So I get 144 here, which works out nicely for our c squared. So that means c is the square root of 144, which is just 12. So that's our c value. Now this next part of it just probably seems kind of silly. Why would you need to know this? Now they want us to find the sine of x and the cosine of x. So they basically just want that ratio. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse. So I have to label everything based off of x. So here's my opposite, adjacent, hypotenuse. So the sine of x, ooh, this one's a little bit tough to simplify. It's probably going to get my head tough. 8 square roots of 2 over 12. The cosine of x is 4 over 12. That one's nice to simplify, 1/3, or 0.3 repeating. Now this one, the 8 square roots of 2 over 12, the 8 and 12 can both be divided by 4. So this becomes 2 square roots of 2 over 3. It's considered the simplest form. You can simplify that 8 over 12. So, what we're going to be doing today is we're doing our last section of notes, which basically combines these 3 trig functions together, and then we also are going to learn how to find the angle measures. So when we know the side lengths, we can actually find those angle measures using trig as well. So yeah, you definitely need a calculator today. Then we're done with the chapter, so we're going to review for a couple days and then test. So we're going to test on Tuesday of next week, so Tuesday the 15th. I don't love Monday tests, especially with our virtual Fridays. It's kind of a long weekend. So just know that we'll review for 2 days, test on Tuesday. So if you guys are still thinking about retaking your last test, let's try to get that taken care of. So you can't come in for AR today, but tomorrow, if you guys are interested in working on corrections in a retake. Now, if you did a retake, I did put those in finally, I think, yesterday or last night or something. So they are, at some point I put them in. So you guys can check that. All right, so I will get you guys today's notes. Today is that when they're gonna, again, we're gonna use sine, cosine, and tangent still, but when their directions to you a lot of time will say solve the right triangle. So when it just says solve the right triangle, that means they want you to find all the missing sides and all the missing angles of that triangle. So if you don't know all the sides, you have to find all of them using either SOHCAHTOA or a squared plus b squared equals c squared. So kind of similar to that last question we just talked about. So those are our two methods to find missing sides. And I think you guys are pretty good at finding missing sides. We've done, I mean, like so far it seems like the homework's gone pretty well for you guys in terms of finding those missing sides. Now what's going to be new today is finding all the missing angles. Now you have actually learned how to find missing angles in previous chapters. What do you know about the angles of a triangle? Add up to 180. So if you know two of the angles, you can find the third. So knowing that the angles add up to 180. However, if you only know one of the angles and you're missing the other two, we now are going to learn that we can use trigonometry to do that. And so what we do with that is called an inverse trig function. So inverse SOHCAHTOA. And I'll show you guys how to find that, or how to do that. So I would suggest having a calculator handy. If you need to grab one, go ahead. So on your calculator, above the sine, cosine, and tangent on your calculator, there's like little fine print. It's not really fine print, but it's like a step above that. You'll see something that looks like this. So it looks like sine with a -1 power, cosine with a -1 power, and then tangent with a -1 power. It's not really a negative, well, I guess it is kind of a -1 power. But what it is, it's called the inverse sine, cosine, and tangent. So the inverse, what that allows us to do is it allows us to find the angles. So anytime you're looking for the angles, you're going to use one of those buttons, which are above the other ones. And I'll show you guys how to do that today, obviously, because that's new to us. It's really the only new thing we're learning is how to find that missing angle. So for example 1, if you notice, we only know one of the angles is 90 degrees. The other one is a question mark, and the other one we don't know, and they don't really ask us anything about it. So we have to find that question mark. And this is where we're going to use one of those inverse trig functions. So we have to pick which trig function we want to use. And we're going to label everything based off of this little question mark. So question mark is across from 32. That's my opposite. Here's my hypotenuse. And then my adjacent. So I know all three. So it's kind of up to you what we want to find. Anyone have a, or which trig function we want to use? Anyone have a favorite trig function? Anyone have a favorite? No? You picked your favorite trig function yet? All right. So let's just use sine. So we're going to use sine, which is so. You could have used any of them. So sine, what's our angle in this case? We don't know. So sine of question mark equals what over what? What does our ratio look like? 32 over 40. Okay. So we know the right side of the equation. We don't know the unknown angle. I can't divide by the sine, but instead of dividing by the sine, which maybe you want to do, this is where we use the inverse sign. It undoes that sign, and it's going to give us the angle measure. So what we're going to do is the inverse sign of this, 32 over 40. It's going to solve for our question mark. Maybe I should write that. So our question mark is going to equal the inverse sign of that ratio, 32 over 40. grab your calculator, because again, this would be really tough to do in your head. And so the inverse sine, you kind of get that from, like a lot of times you have to hit the second button. Like it has to, you have to make sure it says inverse sine. Are you finding that? And then just 32 either divided by 40 or as a fraction over 40. And just so you guys can check if you're doing this correctly, I got my question mark to be about 53.1 degrees. But I want to make sure you're getting that in your calculator as well. So take time to kind of see how to enter it. Again, I really ask you guys use a calculator and not your cell phone, please. Because you won't be able to use a cell phone on your test. So you have to get practice with your calculator. And then try putting that into your calculator. Yep. So you can do fraction, or just division. So 32 divided by 40 is fine. So yeah, division or fraction is fine. Whatever you want to use. You get it to work? So that's our angle measure. And so just knowing that going into this should be an angle measure in a triangle. So does 53 degrees make sense in our triangle? Yeah, I would hope if you saw an answer like 153, you'd be like, oh, that sounds wrong. Or if I got 5, I hope you'd look at the drawing and be like, that doesn't look right. So kind of just making sure your answer makes some sort of sense is a kind of a good thing to do. Questions there? All right, let's look at example 2 then. Now this time they want us to find the measures of angles A and B. I guess I'll just start with A. So my angle A, I'm going to use as my perspective. So my 14 is my opposite, and then 8 is going to be my adjacent. Now I could find the hypotenuse, but they didn't ask for the hypotenuse. So if I wanted to find it, I could, but I don't really need to. So I'm not going to do that. I'm not just going to do extra work to do it. But if you did, it's fine. But what trig function does now tell me I have to use? Which one? Tangent, because it's O and A we know. So we have to use tangent because that's the two sides I know. Unless I went and found the hypotenuse, then I kind of have some options. But I like when their side lengths are whole numbers. If I can stick with whole numbers, it's a little more accurate. So I'm going to do tangent of angle A. I don't know what angle A is yet. Equals O over A. So 14 over 8. So now in order to solve for angle A, that's where we use that inverse tangent on our calculator. So the inverse tangent of 14 over 8. So I should have got like 60.2, I think. All right, so once I know angle A, can I find angle B? Find angle B.
Put it from angle B's perspective.
You could do that. So you could do trig from angle B. So you could like do tangent of B. Otherwise, what's another maybe faster way? I don't know if it's faster or not. Yeah, we know that they should also all add up to 180. Now you could use it. You could do what Michael said first of all. But I think it might be a little bit easier just to do subtraction. We know that this one's 90. And this one's 60.2, so then I can find that one hopefully pretty easy. I think it's 29.8 then, right? That angle B would be. So we're able to find that next angle. 29.7, sorry, wait, 60.2. Oh, that's, like I looked at my previous one. I had 60.3 if I actually rounded correctly. I apologize, but it depends on your rounding. All right. So actually, let's stop for a minute and then do whiteboards to make sure we got this before we move on to solving the triangles, which isn't much different, but I'm just making sure we're good on those. So this side of the room wants to grab whiteboards, please. I was trying to read the whole thing with the mouth. Oh, yeah. Alright guys, so find angle B for me, please. And maybe round to the nearest tenths place, so 1 decimal place. Find angle B. Yes, good job. Yep, good job. Yes. Careful, check which side do you know. There you go, you got it. Yes, good job. Yeah, and then if you wanted around to this decimal place, it was that come. Yes, very good. Yes. Yes, 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 yes. Yes, good job. Yes. 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 There you go. Yeah, just be careful. We should be using sine in this case. We're trying to find angle B, because this is my opposite, and then this is my hypotenuse. So I'm going to do sine of B equals 12 over 16. So then I'm going to do the inverse sine of 12 over 16, and I get like 48.6 when I round. It's like 48.59. So that would round up to 48.6. And just be careful that you do include the degree symbol. So 48.6 degrees, so that we know we're talking about an angle and not like a sine line. Okay? Find question mark here. Yes, good job. Yeah, good job. Yes. Yes. Yes, good job. If we rounded to the 10th place, we would move that. Yes. 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 Yes, good job. Yeah. Yeah. Yes. Yes. Out the door. I once had a really naughty freshman boy who used to like throw things out, like pretend like he was looting something out the door so you could go in the hallway like during class. Yeah. So just like he's like, oh, I have to go get my pen, and like I'm like, wow. Yeah, right. Like, all right, so this time we label everything based off of our question mark. So in this case, here's my opposite. I don't know that though. My adjacent and my hypotenuse. So I want to use hypotenuse and adjacent, or adjacent and hypotenuse. So that's going to be cosine. So cosine of question mark equals 7 over 10. So our question mark is going to be the inverse cosine of 7 over 10. So that'll give us our value of like 45.57, so that rounds to 45.6. All right, this next one's going to give you some options here. I don't know if options are good or bad. Sorry. So this one you can use whatever trig function you want. Just have to set it up correctly. Yes, good job. Yes. So pick your favorite trig function. Yep. Yes. Yes, good job. Yes. Yes. Yes, good job. Yes. Yes. Good job. No. No. Yes. Then, which two sides do you use? You should be using the adjacent then would be the 6.
Oh, yeah, I was looking at opposite.
Yeah. No, it's okay. So, we have our opposite, our adjacent, and then our hypotenuse. So in this case, you can use whatever trig function you want as long as you set up your ratios correctly. Because the sine of A is going to be 8 over 10. The cosine of A is going to be 6 over 10. And then the tangent of A is going to be 8 over 6. And it's just deciding which one you want to take the inverse of. So it's up to you in this case. And so sometimes giving you options is like tougher, or maybe it makes you a little like less sure. But any of those should give us the same outcome. So everybody, I don't even know what a lot of you guys used as which trig function you used, but you all should get the same answer, that's like 53.1. All right, let's do, let me do one more here. So find the value of x. So take us back to a little bit back to our roots here. I want you guys to forget how to do these other types. So this is kind of what we did for yesterday's homework. Yes, good job. Again, you knew how to do this yesterday, so yeah. Good job. Not quite. Let me see what you put in here. So you don't use tangents, that's the hypotenuse. You have the right idea though. So set up, yep. Okay, good. Yes, good job. Yeah, sometimes we go back to something that seems a little older, tougher. Yes, good job. Yes. Yeah, you're so confident. All right, let's talk about this one. So here's my angle. So this time we know the angle. This is my opposite side, and then this is my hypotenuse. So I have to use sine, so I have to use so. So I'm going to do sine of 27 equals my opposite over the hypotenuse, 8 over x. Now remember, when the x is in the denominator, it makes it tougher. We have to put this over 1. So x times the sine of 27 will equal 8. So then we'll divide by the sine of 27. So 8 divided by the sine of 27 gives us our answer of like 17.6. Let's do one more just because that was a little bit rocky, but. That should be a 9 up there, sorry, I realize it looks like a A maybe. Yes, good job. Yes, good job. That's a 9 on the top. Yes, good job. No, I can give it flipped. It's opposite over adjacent. Yeah. Yeah. Yes, good job. Yes. Yeah, you got it. Good job. Yes. Yes. No. Do you have yours flipped? Yeah, it's opposite of our adjacent. You gotta flip it. Yep. Yep. No. No, you have to use sine in this case because you don't know anything about the hypotenuse, right? Yeah. All right, so in this one, you guys, so this is my opposite, and then this is my adjacent. So that means I'm doing tangent, opposite and adjacent, so tangent of 58 equals x over 9. So to get my x alone, I have to multiply each side by 9. So 9 times the tangent of 58 gives me like 14.4. Are we okay, or do you guys want another one? Good. What do you think? I thought someone had an opinion, no? Okay. I guess we can clean them up. So if you guys want to clean them up, take them back when you have a chance. Okay, so guys, these next two problems don't specify what you need to do, like specifically. It just says solve the right triangle. So when you see the word solve the right triangle, all that means is basically find everything that's missing. So it means find all the missing sides and angles. These two happen to only have missing angles. We know all three sides. So basically it just means find all the angles. So in like example 3, you can start with either x or y, it doesn't matter, your preference, or x or z, I guess. We'll start with z. So I'm going to label everything based off of z. So I have my opposite, I have my hypotenuse, and then my adjacent. And then again, we get to pick our favorite trig function because we can use whatever one we want because we know all three sides. Just because I feel like we haven't used it recently, let's use cosine. So cosine of z, so cosine is cot. So adjacent over hypotenuse, so 36 over 39. Now if you're like, oh, I found a different angle first, or I used a different trig function, you should get the same exact answer. So we do z is the inverse cosine, anytime you're trying to find that angle, we have to use that inverse, of 36 over 39. Now it might bug you that you want to simplify that fraction, you don't need to. And I even use division rather than the fraction bar. And so I got like 22.6 for my angle z. Once I know angle z, how can we find angle x? What's that?
180.
Yeah, now we can just subtract. We know y is 90. So we can just subtract them. Basically, I usually do 90 minus 22.6. So we got 67.4 for my x. All right, why don't you guys take a minute to see if you guys can do example 4 if you haven't already. I know some of you guys already worked ahead, but you guys can try example 4 on your own. It's a very similar example. Hey. Yeah, how are you? Good, thank you. Like, oh, yeah, no, today I should off. I know. Yeah, no, right. What's up? Oh, yeah, somewhere. Not there. Yeah. Right. Right, yeah.
Well, I want to play the Navy as a senior.
Okay, so guys, let's check on this.
That's all.
So, what do you guys want to find first? Which one did you find first? You went for Z first. All right, so let's go for Z. We'll label all the sides: opposite, hypotenuse, adjacent. So it looks like Sammy used sine, right? Yeah. So we're going to do sine of Z is the opposite over the hypotenuse. So 20 over 25. And again, it doesn't matter which trig function you use, you still get the same answer as us. So don't say like, I'll use a different one, that's why my answer is different. It should all be the same. So inverse sine of 20 over 25 gives us our Z value. And it's like 53.1, I believe. You guys all get that? Any questions on that for Z? And then again, once I know what Z is, then I can easily find X. Now, if you really are dying to do another trig ratio, you can. Otherwise, you can just do subtraction. So again, I just do 90 minus 53.1 because I know the other one's already 90. So I get 36.9 for my X. Okay. So flip the page over. So we can either solve where we don't know any of the angles and we know all the sides, or we only know one of the angles, one of the sides, and we're trying to find the other sides and angles. So again, when it says solve, we want to find all these missing pieces. So I have M, X, and Y to find in this case. Does anything jump out at you that you want to find first? I think there's something that should be really obvious and be easiest. Yes? Yeah, we already know one of the angle, or two of the angles really. We know the one is 90 and we know the other one is 25. So I can find that third angle just with the subtraction we just did. So I know it's going to be 90 minus 25, which gives me 65, right? Yeah. So my M is 65 degrees. So I already found that other angle. So if it helps to list that, M is 65. We're still trying to find X and Y. So at this point, how do we go about finding X or Y? We're going to have to label everything based off the angle we want to use. What angle do you guys want to use? Your preference? 25. The 25? Okay. So 25 degrees. This is my opposite. This is my adjacent. And then my hypotenuse. Now again, if you chose to use the 65-degree angle, you should get the same outcomes as us. These answers don't vary depending on which perspective you use. So I have to somehow use the opposite because of the fact that I know the opposite, I don't know the other two sides. So for SOHCAHTOA, I definitely can't use cosine because I don't have the A or the H. So I'll start with tangent. So tangent of our 25-degree angle is my opposite over my adjacent, so 10 over y. Now some of you guys might have been saying, well now we should have used that 65-degree angle, and that's fine if that's what you did instead. So cross multiply. I got like 21.4 for my y. That's over here. Now it's up to you guys. How do you guys want to find x? Do you want to use trig or do you want to do Pythagorean theorem? Theorem, you said? Yep. So at this point, we know the two short sides. I'm trying to find the hypotenuse, so I'm going to do a squared plus b squared equals c squared. So a, b, and my c. So my a squared is my 21.4 squared. My b squared is 10 squared. And then my c squared is my x squared. Now again, guys, when I do this, since I have 21.4 still in my calculator, rather than retyping that, I just square it right there in my calculator. So if I hit squared, it squares the previous answer. Then I add 10 squared to that, so I'm going to get 559.9 for my x squared. I'm going to take the square root of that answer, and I find out my x is 23.7-ish. And again, going back and looking at your drawing, making sure that makes sense. If this is the hypotenuse, it better be the longest side. All right, and then we'll finish up with our last example. Now this one, and then when we're done, you guys will have the rest of the time to work. We don't have AR today because of ACT, ACP, so I don't want you to not have that time. I know you guys have busy stuff going on. Just a reminder, stay on top of things so you don't have to be called in for Friday. I don't think many of you are in that situation, but make sure you kind of stay ahead of the game. So, now this one, they give us the 18, so we can find that other angle. So I'm going to do 90 minus 18, which is 72, right? So I found angle A is 72 degrees. Now I'm going to label everything based off of 18. Now this one I'm going to be kind of strategic. I'm going to use tangent. The reason for that is because I like the fact that the adjacent's in the denominator already. So I try to be kind of smart about just like how many steps I have to take. So I have tangent of 18 equals the opposite over the adjacent. So this time I can just multiply by 9.2. And I find out y is a small number, which makes sense though for my drawing. It's 2.99, so just basically 3. And then I still need to find x, which is my hypotenuse. So it's up to you if you guys end up using Pythagorean theorem or trig again. So I have my A, B, and C. My C has to be my longest side, which is over here. These are my A and B. So I'm going to do 2.99 squared plus 9.2 squared is going to equal my x squared. Be like 93.58. And I find out x is about 9.7. Alright, is that okay? So just a reminder, if you're struggling on any of this, please stop in over the next few ARs after today. Again, we're testing on Tuesday, so kind of plan ahead for that. And then homework is, let's go there.